Thanks for joining us again. Now, today's topic is a controversial one, especially when it comes to the thyroid hormone optimization community. Because what I'm going to talk about is why you should not why you should not be pulling, obtaining, or even monitoring a patient's serum reverse T3 levels. All right, as a quick primer, in the event you don't know what reverse T3 is, what it is a biologically inert, which means it essentially doesn't do anything. It's a biologically inert stereoisomer of T3. So there's these three enzymes. There's deiodinase 1, deiodinase 2, and deiodinase 3. And these enzymes, particularly D3 or deiodinase 3, is an enzyme that's responsible for catalyzing T4 into reverse T3. And so once reverse T3 is formed, it's speculated that what it does is it binds and occupies the T3 receptor site. However, since it's considered biologically inert, it's not doing anything, it's essentially just sitting on the receptor site. It's occupying the T3 receptor site, and therefore your active T3 is enabled to access that receptor site. Okay, now that we got the brief primer out of the way, let's move ahead and talk about why you shouldn't test for reverse T3. Okay, so the first reason why you shouldn't test for reverse T3 has to do with the way that T4 degrades, the way that T4 actually goes down to its pathways. So, roughly 40% of T4 will become deiodinated, which means it loses an iodine molecule, and it will become T3. And roughly another 40% of it will become reverse T3. So it's about 50-50. It's 40-40 technically, but it's about equal between the two. So say if you have 100 micrograms of T4 is what you placed a patient on daily, we know that roughly 40% of that will become T3, and we know that roughly 40% of that will become reverse T3. So what this means is the higher the doses of T4, well, guess what? You're also going to have higher amounts of reverse T3 because there's more of it to go down that pathway. So let's look at this way. Once again, say if you got them on 100 micrograms of T4 a day, we know roughly 40% becomes reverse T3, and we know roughly 40% becomes T3. You do the math. If we up the dose, then we can say, you know what? There's going to be even more going down each pathway. So, first reason why is because higher doses of T4 will inevitably have a good chunk of that go down the reverse T3 pathway. So the next reason why you should not test for reverse T3 has to do with the actual degradation of reverse T3 itself. So reverse T3, it degrades, it breaks down much faster than T3 does. Now, the old school, or at least the functional approach to treating patients with high reverse T3 was that they would put you on more exogenous T3. So say if your reverse T3 is high, 17, 18, 20. The old thought was, well, if that's high, that means you're poor at converting T4 to T3. And instead, a lot of it's going down the T4 to reverse T3 pathway. So what they thought was, if you're a poor converter, we just need to dump more T3 at you. We need to just add more and more T3 exogenously to overcome a quote unquote poor converter status. Now, let's talk about what I just said a minute ago. Reverse T3 degrades faster than T3 does. So what's going to happen is if you keep adding more T3, more T3, more T3, you're going to have a cumulative compounding effect. And then what's going to happen is you're going to accumulate too much T3. I've seen plenty of patients come to us that have been on this kind of philosophy of treatment, and unfortunately, a lot of them are iatrogenically, they're medically induced hyperthyroid because they're getting way too much T3 in an effort to overcome poor conversion status. Again, that's not a good approach. Doesn't work that way because reverse T3 again is going to break down faster than T3 will. Okay, and moving on, the next reason why you should not test for reverse T3 is because that most immunoassays are not accurate. Let me repeat, most of those blood tests that you do are not accurate. In fact, a lot of those reverse T3 tests, well, guess what? A good chunk of T4 actually registers as reverse T3. So when you're pulling the reverse T3, you're not really getting a true accurate reflection of what you're getting. You're actually getting some of that T4 spilling over and being registered at it. And as I mentioned earlier, roughly 40% of T4 does convert to reverse T3. So therefore, if you do have the patient on exogenous T4, especially if you have them at higher doses, we already know it's going to be higher than it should be, and thus it's going to be falsely elevated. And reason number 4 why you should not test for reverse T3 is simple. It's because as you get older, your body naturally has a predilection towards making more reverse T3. It's a simple protective mechanism. And the reason being is because as you get older, we become more hypersensitive to the actions of T3. Hence why one of the biggest precautions we need to take, especially in patients 55 and older, especially when we put them on thyroid replacement, is to caution that or be precautionary that we don't actually give them too much because it can cause heart palpitations, it can cause rhythm disturbances, with atrial fibrillation being one of the most common possibilities or most common consequences of giving too much T3. So again, reason 4 is because as you get older, your body naturally has a substrate predilection towards going down the reverse T3 pathway, and this is completely protective, especially in terms of protecting from going into an accidental hyperthyroid state. The fifth and final reason I want to talk about why you should not check reverse T3 is because in states of illness, reverse T3 will be higher. On top of that, the clearance of reverse T3 will also be reduced. So you're going to have more of a net effect. So say if you have a patient that comes to you that has hypothyroidism, well, guess what? Hypothyroidism is an illness. So we already know it's going to be higher than it should be as compared to a non-hypothyroid counterpart. And as I also just said, the clearance of it decreases as well. So you're going to have that net effect. So to wrap it up, you don't treat reverse T3. You don't pull the labs for reverse T3 because there's too many confounding variables and too many inaccuracies with the test. Again, merely treating somebody with thyroid medication is going to skew the value. Merely having hypothyroidism is going to skew the value. We're not treating people for inaccurate or inconsistently partially accurate tests. What we're treating them for is symptom resolution. And ultimately, that's the goal, is to give the patient a better quality of life and not be chasing blood work.
Leave a like and comment under this video and check out my new ebook Acne on TRT.